Okay. Okay, good morning, everyone. I think we're going to go ahead and get started. So we wanted to welcome you to this morning's workshop, Evidence-Based Data Visualization. This is the first workshop in the PDHP workshop series of 2020, so we're happy to get things started again. My name is Brady West. I'm the director of the Scientific and Technical Core of the Population Dynamics and Health Program. We have up here on the screen the web page for PDHP. This is a program that's within the Population Studies Center here at the Institute for Social Research at the University of Michigan. And you can see here that PDHP is funded by a center grant to the Population Studies Center from NIH. Provides resources and services that support innovative approaches to data collection and analysis and the development of early career population scientists. So we have a particular focus on providing support to people who are trying to write proposals, get research funded, get papers out the door. So we provide services in that regard, and we provide resources for people to develop proposals, especially junior faculty and junior staff who are getting started in their careers. So PDHP has a number of affiliates across the university. So if you're interested in becoming an affiliate of PDHP, which would open the door to some of our services like statistical consulting, proposal support, and so forth, you can see more information on how to become an affiliate of PDHP on the PDHP website here. So we would welcome additional applications, and we would definitely look forward to working with you. So the Scientific and Technical Core is one core of the PDHP itself. I'm here with Paul Schultz today, who set up this workshop and really organizes the whole workshop series. So I want to thank Paul for his hard work in getting all this together. So we're really looking forward to another good workshop series here in 2020. Okay, so today in this particular workshop, just some logistical details. We will be running from 9 to 1. Paul is going to be sending around a sign-up sheet, so make sure to write down your name if you're in attendance and your affiliation, where you're coming from. We'll also be tracking those of you who are listening on BlueJeans online to see who's here, so we'll be keeping track of attendance in that regard. So thanks to those of you who are joining on BlueJeans for joining us this morning. And you will be able to chime in. We would ask that everybody who's listening on BlueJeans keep your microphone muted. But if you do have a question at some point during the workshop, please feel free to chime in and just remove your muting and then just ask a question, and our presenter would be happy to answer that today. So we will also be having a evaluation form. We'll be sending around evaluation forms after the workshop concludes. So make sure to fill that out and give us some feedback about what you thought of this particular workshop. Both Audrey and ourselves will be taking a look at those feedback forms and making sure that we're developing the best possible workshops moving forward as part of the series. So we do take that feedback very seriously, and it's a good way for us to evaluate the programming that we're working on. So please do take the time to fill out that form after you're done today. And those of you online, you'll get an email where you'll have a chance to fill out that feedback form after the workshop is over. Okay, so Paul is going to be monitoring the chat as we go. So if you don't want to chime in online or chime in via audio, just feel free to send a chat message, and we'll monitor if there are any technical issues or any concerns or any questions for Audrey that people want to ask, and we'll bring those to the table as well. So feel free to use the chat tool as well if you would like. Okay, so let's get into the content today. We're very, it's a pleasure today to have all of our presenters as part of this workshop series, but today we have one of our own. So Audrey Michael is a cognitive psychologist, and she has research experience in cognitive neuroscience, data visualization, and scientific reasoning. She's currently an assistant research scientist in the Department of Psychology here at the University of Michigan. She works with Dr. Preeti Shah. Audrey has experience with a range of research methods, including functional neuroimaging, eye tracking, and behavioral methods. In her current line of research, she investigates the best way to teach middle and high school students scientific reasoning skills. So she's working on some very interesting things and has some good experience with today's topic, which is data visualization. So really looking forward to this, and with that, I will turn it over to Audrey.
Thank you, and thank you guys for having me. Really excited to be here and share some of my work with you guys, and also talk about some really, hands-on practical advice for how to explore your data sets and also create some nice-looking data visualizations. So let me navigate back to my presentation real quick. Yeah, as Brady mentioned, I did a lot of research as a postdoc on data visualization in kind of more the end of how people interpret data visualization. So not so much the design end, but kind of going back to the basics of how do we actually interpret bars and points and lines. And I was coming at this from a visual cognition perspective. So my degree as a graduate student was in visual cognition and cognitive neuroscience. And so, I was learning a lot about the limits of the visual system and, how difficult it is for us to actually do something like look at a graph and figure out what's there, even for very, very simple graphs like a 2-bar graph. First I'm going to talk you through just a little bit of background on data visualization and some of the broad research that has been done on interpreting data visualizations from a cognitive and visual cognition perspective. Then we are going to go into learning about R and ggplot2 specifically, which is a really nice package for creating data visualizations. Have you guys had experience with ggplot2? Okay, so it has a lot of great features both for data exploration and data explanation, which is kind of the part where you make a pretty data visualization. So we're going to talk about both aspects of that today. I'm going to have you guys do some exercises just to get you used to the software if you're not familiar with it, playing around with some features. And then I also have a couple extension packages that are pretty exciting that we're going to work with today. So it's going to allow you to visualize data on a map using ggmap and also animate the data using ggAnimate. Okay. So we'll back up and just start with what is a data visualization. So this is a term that's kind of caught on more recently, but it used to be called graphs, right? When we talk about graph comprehension or graph design, data visualization is kind of a newer term, and it's actually a subset of something more broad referred to as information visualization. So information visualization essentially is a similar idea where you can visualize other types of information that don't necessarily have to be data, right? So you can visualize things like how networks look, right? That's not necessarily data, it's just a visualization of connections, right? So today we're going to be talking specifically about data visualization, things like plotting, bar charts, scatter plots, line graphs, and we are going to get a little fancier than just these basics, but that's kind of what I'm referring to when I say data visualization. So we know now that many people, other than scientists, are interested generally in data visualization, right? So people in all walks of life are interested in doing things like visualizing financial information, health information, maps and chloroplasts are really popular now to see, population dynamics and other things like that. And also just kind of visualizing, multiple patterns that might be relevant for a business or really anything. So it's really caught on, especially now that data is so easy to get, right? It's the time of big data, so it's very easy to get rapid amounts of large data sets. And now people are just trying to figure out what's the best way to deal with that data and visualize it in a way that's not completely overwhelming for people and usable and meaningful. So I'm just going to outline some general goals of data visualization. So typically, people are using data visualizations to communicate information, but the goal is usually to do this in as clear and efficient way as possible. Also to be engaging, right? So there's now some trends for people to use like icons or pictures or something to jazz up the visualization so that they're not only informative, but also memorable. And then also, as kind of a separate goal other than communication is exploration. So if you're in the data analysis phase, you may not know exactly what you're looking for in your data. You just kind of want to get a sense of, what's the distribution of your data? Are there outliers? What kinds of hypotheses can you generate? So that's another goal. Some people have a goal of automatizing data visualization, right? So they want to be able to just put in a data set and have a computer generate a data visualization or some kind of analysis in like an algorithmic way without a person doing it. So there are people working on that problem. Of course, aiding decision-making. So evidence-based decision-making is very big right now, which is great. But it's not always clear, what kinds of evidence is relevant for a given decision. So it can be helpful to aid in decision-making across all kinds of fields. And then finally, we have also been using graphs and data visualizations to try to improve learning, specifically in the scientific reasoning realm. So this is kind of another goal that I'm personally exploring. Okay. So as I mentioned, there has been research from the cognitive perspective on data visualization. As I said, it used to be called graph comprehension. So a lot of this work, you may not see it if you Google data visualization and cognitive science. I would recommend, Googling something like graph comprehension, because that's the term that was used at the time. But essentially, this kind of work is interested in how do people perceive, interpret, and reason about visualizations. Because honestly, visualizations are a very new thing, right? They've been around for, less than like 300 years, right? Like the first visualization started popping up very recently in time. So we actually don't have a great sense of how people represent these visualizations, how difficult is it for people to interpret them. And specifically, we're interested in what types of errors people make when they're interpreting data visualizations. Are there specific biases people have? People don't always look objectively at data visualizations, right? They come to the table with some kind of prior knowledge or prior belief, and how does that affect the way they interpret data? So this is just some of the research here that is kind of this earlier work. You can see it's from the 90s. A lot of this work was done by my advisor, Preeti Shah, and just kind of understanding the basics of how people go about interpreting graphs and data visualizations. One of the takeaways from all this research that's very similar to my own takeaways from research in visual cognition is that graphs require much more slow and effortful analysis than most people assume. So, I think there is this perception out there that data visualizations are intuitive, that you can just look at a graph and get an insight from it very quickly. And of course, that is a goal that many people have, but it is very difficult to get to that point. So most graphs are actually very difficult for people. It requires kind of this slow sequential processing where you don't just look at a graph and understand it as a picture. You actually have to break it down into little pieces, figure out, which legends correspond to which data points. It can take a long time, essentially. So if we kind of take a step back and get to that point of, understanding, well, how do people actually do this? How do they go about looking at a graph, figuring out what's relevant, and understanding what's going on? We still are learning that, right? This is an ongoing line of research that we don't have all the answers to. So so basically we do need to keep working on this and try to understand, if the goal is for people to have very clear insight about what a graph is, or how to design the best graph. We need to know more about how people are actually perceiving and interpreting them. So when I was a postdoc working on graph comprehension and data visualization, I was actually working with very simple 2-bar graphs. So nothing fancy, just showing people 2 bars and trying to see how do they perceive them, how do they interpret them. And the theoretical framework we were working from in that lab was the idea that this kind of analysis is actually very slow and sequential, and that even if you're just judging, for instance, which bar is taller, the left or the right, that is going to actually require you to shift your attention between the bars. You don't just get that information all at once, even if you feel that way. So this had been shown for other kinds of visual information, this idea that you have to kind of shift your attention spatially between items, and that it's much slower than you might think. And we wanted to test the idea that this is also the case when you're comparing something like magnitude or the size of bars, which one's taller, which one's shorter. And specifically, our hypothesis was that if you look at bars in a certain order, right, you can either choose to look at the taller bar first or the shorter bar first in this case, that's going to kind of directly affect how you interpret that graph. And that's important, right, because you can either come away with an interpretation that the shorter bar is on the right or the taller bar is on the left. And that actually has different implications for your understanding of the graph. So in this study that I'm going to talk about, we use eye tracking to basically just figure out which bar people would look at first in a similar kind of setup. We tested college-age participants, and we also tested young children to see if there were any developmental differences in how they approached the task. So I'm just going to give you a sense of the task real quick. So first, we either showed a question to college-age participants or read the question out loud to the children. Some of them were, too young to read, like 6. So we read them the question. It was always phrased as, like a magnitude comparison. So are there fewer bananas than blueberries? And then we'd show them the graph. So what do you guys think? Yes or no? Yes. Okay. So the answer is yes here. There's fewer bananas than blueberries. Okay. And we introduced the mappings of the colors to the fruits beforehand too. Okay, let's do one more. Are there more limes than blueberries? Right. No. Okay, so it's actually kind of hard, right? There's only 2 bars here. There's just one question you're answering, but it takes you a while to figure out, which bar to look at and make the comparison in your head. So if you guys had to guess, before I show you the data, where do you think people would look first in terms of either the spatial location, like left bar, right bar? Do they look at the color first? Do they look at the taller one, the shorter one first? What do you guys think? So let's say for this specific example, where the question is, are there more limes than blueberries? Where do you think they'd look first? Tall, because of the more, right? The more gives you the clue, like I'm looking for the big one. Okay, yeah.
Or limes, because it's the first one listed.
Mm-hmm, yep. So theoretically, there's like multiple ways this could be done, right? My prediction was also, like you guys said, that people would look at the taller bar first when it was phrased as more, or the shorter bar first if it was phrased as fewer, right? So I'm going to show you first some eye tracking videos of just one child in this case. So in addition to measuring their eye movements of which bar they looked at first, we're also recording how quickly they respond, yes or no, to that question. So this is a video here of a child, an 8-year-old child, who's answering this question, are there fewer blueberries than oranges? And overall the trials we sampled from this participant, they tended to be slower on these kinds of trials, okay? So I'm just gonna show you real quick their eye movement pattern. So did you guys catch which bar this child looked at first?
Yeah.
Okay, I'll show it one more time. Yeah, it was the left. Okay. So first of all, the left bar is not the shorter bar. So that theory that people look at the shorter one, depending on whether it's fewer or more, didn't happen. Blueberries is the first fruit in this case. They didn't look at blueberries. They looked at this left taller bar, right? So you can imagine it's going to be difficult for this child to align how they looked at the graph with the question that they have to answer, right? Because the question is, are there fewer blueberries than oranges? And the way they're looking at this graph is big orange, small blue, which is in the opposite direction of the question, right? So that could explain why this child is slow on these kinds of trials. If they're looking in a way that doesn't map onto the question order, it's going to take them longer to flip it in their head and answer the question, okay? Now I'm going to show you a different child, so another 8-year-old who tended to be faster on these kinds of trials. So in this case, their question was, are there fewer oranges than blueberries, okay? Okay, so now, I don't know if you caught it, but this child looks at the shorter orange bar first, right? And this is great because both the fewer shorter maps on and the oranges is the first fruit mentioned. So they're now looking at this graph in the same order as the question is phrased, which could explain why it's faster for them, right? So we would refer to this kind of attention strategy of like choosing how to look at the graph as a visual routine, okay? And in this case, this child's visual routine is congruent or in the same order as the question. So I've just shown you some cherry-picked examples, but if we look at the data sets over, all the children, we can first see what are their spatial routines in terms of, do they look at the left bar first or the right bar first? Because that first child I show you looked at the left bar first, but we want to know how often is that happening, across all the trials. The identity routines on this side is going to be routines where the child uses the order of the question. So looking at the oranges bar first if oranges is mentioned first, okay? So those were kind of the two major routines. We saw, as my hypothesis, that people would use the more fewer did not pan out. So first, what I'm showing you here is for our college-age participants. So this line in the middle is kind of the 0 starting point. So they're always starting in the middle of the 2 bars. And we're just measuring, on average, how much do they look at the left bar first versus the right bar first. So each black dot here is an individual participant. And essentially what you see is there's no spatial bias for adults in this task. It's not like they're always going to the left bar first or always going to the right bar first. What we're also plotting on the y-axis is their reaction time overall. So their average response time and seeing is there a relationship with their average spatial routine. Okay? So you might imagine if they do have a strong spatial bias, that's going to be a suboptimal strategy in this task. It's going to slow them down. So, the stronger their bias, the more slowly they're going to respond on average. So now when we look at the 8-year-old group, so we're plotting the same type of spatial routine. First, you can see there's a shift overall to the left. So on average, these 8-year-olds do show a tendency to go to the left bar first. The second part of this is there is a relationship here where kids who have stronger left first biases are slower overall, okay? And that pattern holds up for the 6-year-olds as well. So they have an even stronger left bar first bias. So on average, they're going to the left bar first every time. And the kids who have the stronger left bar first biases are slower overall, okay? So what this suggests is that a spatial routine in this task is not optimal. It's going to slow you down. And the second part is that we see this pattern much more frequently with young kids versus adults who don't. Yeah.
We have a question from the chat. Would the spatial routine change if the child grew up learning a right to left language?
Yes, probably. So we did not test that, but one of our speculations about, why are young kids showing this strong left first bias is because we're in a Western culture, they're learning how to read and write. Even without reading and writing, right, in education, left to right is a very strong bias that's introduced in the education system. So yes, this could reverse in cultures that do right to left.
Has anything to do with handedness.
So we didn't see any differences with handedness, but we also had kind of small sample here, so it's possible. We didn't probably have enough to look at that relationship. Yeah.
Does color matter? Because I noticed just from the two examples that the color that tops the most, the orange color, is the one they looked at first.
So we didn't see any systematic changes with color. And I should mention, in the study, we only used the 3 colors. So comparing, yellow, blue, and green, for instance.
You didn't do a grayscale?
Sorry?
You didn't do a grayscale?
No, we did not do a grayscale version. Yeah. But yeah, that would be interesting too, to see. I think because we had all the different combinations, right, they probably got used to seeing the different colors in different contexts. So yeah, we didn't see that. Yes.
Just a quick question
Uh-huh.
on that. The colors were then always tied to the question.
Yes.
In such
Correct.
colors. So
Mm-hmm.
the hypothesis that they were looking at the more visible color, not addressed.
It's not
Addressed.
addressed.
Right. Because the question is like, were they attracted to the more visible color, the orange or the green?
Right. So there weren't any systematic differences. Yeah. Yeah.
You didn't randomize
It was random. I mean, all of the combinations were presented and randomly.
So were there ever any questions where the legend changed, where orange wasn't associated with orange?
No. Yeah. Okay. So now I'm going to walk through the identity routine. So now we're using the same data. We're just looking differently to see, is the bar that they looked at first the first mentioned fruit, right? So in the case of, are there fewer oranges than blueberries? Are they looking at the orange bar first or the other one? So we refer to that first mentioned fruit as a target bar, and the reference bar is that second mentioned fruit. Okay. So now if we look at the adults in terms of their overall bias, we now are seeing a significant shift where overall adults are using this target bar first routine. So they are using the question to guide how they look at the graph, okay? And there is a small but possibly informative relationship here where people who use this strategy more frequently tend to be faster. So this does seem to be the more optimal strategy, okay? Now we look at 8-year-olds and we find an interesting finding here that actually some 8-year-olds are also using this strategy, right? So I showed you at the beginning an example of an 8-year-old who did use that strategy. So we did have some 8-year-olds doing this. And we also see, again, this relationship such that the more frequently they're going to that first mentioned fruit first, the faster they are overall. But when we get down to the 6-year-olds, first of all, there is no overall shift. So basically, 6-year-olds have not learned how to use the question order to guide their eye movements to the bars. So yeah, they're basically at 0 on average. And there's no relationship between, how often they're using that target bar first routine with their response time. So it has no relationship to their behavior, essentially. Okay. So overall, what we can see is that over the course of development, so from the 6-year-old group up through adults, it seems like kids start off with this very strong left first bias. And I already kind of went over some ideas we have about why that might be because of school and learning and emphasis on left first. But as they get older, they stop using that as a default strategy. And instead, what seems to be happening is that people are learning how to use the question to kind of proactively figure out how to organize their eye movements so that how they look at the graph is optimal for their ability to answer the question. Okay. Yeah.
Were there any differences in terms of the order of the question aligning or convoluting with the order of the bars? For example, the first question that you presented to us were bananas versus blueberries, but yet the order was shifted in the graphs. The second one that you presented was limes versus blueberries, and the order was aligned on the graph.
Right. So this is collapsing across both of those conditions. Yeah.
You didn't find that as a stronger driver?
No, and we had equal amounts of each. So yeah.
It kills me.
Huh?
It kills me, so.
Yeah. Any other questions about this data? Okay. So as I said, we were, coming at this more from just a perspective of trying to understand how people interpret graphs, and again, showing that even for very simple questions, very simple graphs, it takes a while for people to learn how to do this, and there seem to be kind of optimal and suboptimal ways of doing this, right? So it's not the case that graphs are easy and everyone knows how to do this. We have to learn. We basically have to learn how to optimally look at data visualizations so that they make sense to us, right, in the best way possible. So the takeaway here is that also there's some individual differences. We looked at age, right, but you could see even in the adults there was some range in how frequently people were using the most optimal visual routine of matching the order of the question. So this also suggests that we can't assume everyone is looking at graphs the same way, right? Just at the beginning when I asked you to predict, like, how do you think people would look at this graph? There's lots of different ways you could do this very simple problem of just interpreting two bars, right? So, so we can't always assume that people are looking at our data visualizations in the way we think they are. So next I want to talk about some other research that could potentially be informative for designing more useful or more easily interpretable data visualizations. So this is work done by Preeti Shah, again from the 90s. So this has been around for a while, but it generally kind of builds on this idea of Gestalt grouping. So Gestalt grouping is generally the idea that how things are grouped together visually, either by how close they are. So in this case, proximity, grouping by proximity, is just the idea that these bars here are kind of chunked together, and that's a separate group from this chunk and this chunk. So we're thinking about data points in this case as individual pieces of information that can either be chunked together or kind of separated, right? So we have four different groups of chunks here. And as it turns out, generally when things are grouped by proximity, so things that are closer together, tend to be compared more easily, right? So having this within group chunk of, in this case, it's showing year information, so 1820, 1840, 1860. This kind of organization kind of more easily allows you to compare this overall trend of the population increasing over time. And if you compare that to the same data here plotted in a very different way, so we're just grouping now instead of by year in this variable, we're grouping by region, so the urban versus rural south and the urban versus rural north. You could still pull out those trends. So if you focus, for instance, on these dotted bars increasing over time on the x-axis, that is essentially the same data plotted here, but it's just much harder to see that pattern, right? Because of this grouping. You're basically fighting against how the visual elements are coming together. So the takeaway from this paper was that grouping can actually be used to an advantage. If you want to encourage people to compare your data points in a certain way, grouping them together is a better way to do that. Okay. There's also grouping by similarity, which in most cases in data visualization has to do with color similarity. So the idea here is that when you have the same color in, for instance, a data point and an axis label or a title or even a legend, right? We use little colored squares to figure out, which variable to look at in the graph. Having that color mapping is really helpful to help people figure out the correspondences between, for instance, text and things in your visualization, so text in the titles or axis labels, but also between different data points, so helping you group, which group of data points belong together. Okay. This is actually a figure from a paper that was measuring eye movements while people looked at scientific diagrams, so not data visualizations, but essentially the point here was that when they colored in labels that mapped onto, the description of the figure in the text, it was much easier for people to make those comparisons, and they saw in the eye tracking data that, people were much faster at basically going between the image and the text because of the color mapping. And the same idea applies in data visualization. It's just the idea that having color signals, where to look, and it gets you there faster. I've also done some work with grouping and data visualization. And in this case, we came up with a graph comprehension intervention for high school students. And the goal here was to kind of teach them how to flexibly group different sets of bars. So, in this case, I have four different levels of, four different data points that vary between whether the team was a junior varsity or varsity and whether it was game 1 versus game 10 in their season. And we played around with teaching them how to group either, these two bars versus these two bars, so the red versus blue. We also have a condition where we group like these two together versus these two together. We also had this line here, which was supposed to emphasize the interaction effect here, so showing that this difference is larger for the junior varsity versus the varsity. So we were playing around with color similarity in that study. And also another Gestalt principle, which is called grouping by common fate. The idea here is that things that move together are also more easily grouped together. So in our intervention, we actually had these data points moving in different ways. So here, this is using both color and common fate to really emphasize, here you're grouping the first two bars versus the second two bars. Here, this comparison is more difficult for people when they have to compare bars that are not adjacent, right? So here we're helping them by giving them both the movement and the color, okay? And essentially what we found in this study is that teaching students to look at graphs this way and helping them, group in different ways helps them interpret graphs better. Finally, this is another goal of mine, which is to see if there's potential to use data visualization as a pedagogical tool. So not just for conveying information, but also possibly improving the way we understand scientific concepts and scientific reasoning. So for example, one of the graphs I developed for that intervention study was a graph showing temperature, average temperature in 2 different cities, Sydney and Chicago, and also in 2 different months corresponding to winter and summer, January versus July. And the question that we were asking students to think about in this case was a question about seasonal changes and how the tilt of the Earth kind of creates these seasonal changes depending on whether you're in the northern hemisphere, like in Chicago, or in the southern hemisphere, like in Sydney. And typically this kind of concept is shown with a graph like this, where they show physically a picture of the Earth tilting, going around the sun, and you're supposed to like somehow interpret the exposure of the sun at different angles changes depending on whether you're in the northern or southern hemisphere. But this basic concept can also be illustrated as an interaction effect in a graph, right? So showing, for instance, that you have a larger difference between January and July, your winter and summer months, in the northern hemisphere than in Sydney. Part of that is because Sydney's closer to the equator, so they have kind of more consistent temperatures all year round, whereas it fluctuates more for cities that are further away from the equator, right? So just kind of exploring whether we can actually use this format of a data visualization to highlight these kinds of more complex scientific reasoning abilities. Okay. So the next phase of this is we are going to start working with R and ggplot2. So I'm going to assume, I know many of you have used R and ggplot2, but I'm going to kind of work from the perspective that you might be a novice. So I'm going to take it slow because I know some of you are. So here I just first have a list of all the things you need to download. So it's a lot. But first we have the RStudio package. So there's a couple different formats of working with R, but RStudio is very user-friendly, and I like it. So you can download it there. There are several R packages. So ggplot2 is the main one we're going to be working with today. And you can actually install that directly once you get RStudio downloaded and opened. If you just type install.packages, quote, tidyverse, tidyverse contains ggplot2 and other functions that are related to it. So you can do that directly in the console once you have it downloaded. ggAnimate is an extension package. So several people are developing other tools essentially to use with ggplot2 to enhance the features of ggplot2. So ggAnimate is one that essentially allows you to create GIFs and movies from separate frames of data visualizations that you make. So there is a ggAnimate package for that, and also something called GIFski, which allows you to actually render it as a GIF. Okay, so that's required for that. The second major extension package we're going to be working with is called ggmap, and I'm going to walk you through this, but unfortunately, to use ggmap, you actually have to create an account with Google Cloud Platform, which I will walk you through. You don't have to do that, but you won't be able to get the map. So it's your choice. The platform is free for a year, so you can just sign up for a trial for today and then delete it if you want, but you will have it for a year if you want to keep it. And then finally, the data set is just on Google Drive, so it's an Excel spreadsheet. And here's the link to that. So you'll definitely want to download the data if you want to be working today. And I would recommend saving it as an Excel spreadsheet because RStudio does allow you now to import directly as an Excel spreadsheet. So I will give you guys some time to download things. Does that sound good? Okay, maybe we'll take like a 10-minute break while people download and get some coffee, and we'll come back, okay? And if you have any questions about installing things, just feel free to let me know. Okay, so as you guys are downloading everything, I just wanted to kind of show you what your RStudio window should generally look like. If you have this open. So I've actually already imported the data set. I'm going to walk you through how to do that next. But your data set will show up here. This is the console where you're actually going to be typing your commands to create your data visualizations and do any other transformations of the data. Here, if you click on packages, you'll hopefully see those packages like ggplot2, ggAnimate, Gitzy, all those that you just downloaded. And you just want to go ahead and make sure that you've checked off the box for those packages. You can also call those packages by typing library in parentheses, the name of the package in quote. Or you can do it this way. Either way, just to load the packages. So it doesn't automatically do that for you. So once you guys have that set up, I'm going to now walk you through how to import the data set. So the data set either is going to be an Excel file if you just did it the way I showed you on the PowerPoint, or if you're having issues with Excel, it might be a CSV file. That's fine. It'll just be slightly different if you do it that way. So what you're going to do is you're going to go up to this panel up at the top right and click on Import Dataset here. And then if it is an Excel file that you downloaded, just click from Excel and then click Browse here to find the actual file that you downloaded on your computer. So in my case, my file is in my Documents folder here. So you just click on the actual data set and then you'll import it into your own RStudio. I'm not going to do that because I already have it, so I'm just going to cancel for now. And then once you've found the file, you'll just click Import here down at the bottom. So I called the dataset AA crash. You might want to also call it something like that, just short, because we're going to be referencing that name a lot. So you don't necessarily want a really, really long title for your data file. This is collision data from, there's a website, I'll find the exact website, but essentially it's a website that keeps track of every single car collision in the state of Michigan, and it gives you information for each collision about what day of the week it was, what were the road conditions, those kinds of things. And specifically, I am showing you data from Ann Arbor. So AA is Ann Arbor, and I will show you quickly what that looks like. So if you go back to the PowerPoint, if you're following along, this is a tool that this website that keeps track of all of the Michigan car collisions has, which is really nice. It's called their data query tool. And essentially it allows you to select regions of Michigan. In this case, I was able to actually just draw a little rectangle in the specific area I was interested in. Does anyone recognize this road? It's like a death zone, right? So this is part of my daily commute, which is why I'm really sensitive to this. But essentially, this is M14. So 94 is coming in here, and then it's M14. And this stretch is where people come in from Main Street or US Business 23 coming in here. There's also a really dangerous entrance off of Barton where you have to like stop and then, you know, go from a stop to 70 miles an hour while incoming traffic is coming at you. So this is for 1 year, 2018, all of the collisions that happened just on this one stretch. So it's very, very dangerous. I hope you don't have to drive it very often. I have to drive it almost every day. So I'm very sensitive to it. But essentially, each of these little markers is a separate collision, okay? So again, this is great. We get a map. We get to see, you know, wow, there's tons of collisions that happen in this stretch from just this data query tool. You can do other things in this data query tool, like you can get a bar graph or, you know, other types of visualizations besides a map. But essentially what we want to do is take this data set and play around with it in ggplot2. So we're going to get fancy with this data set and kind of map things like how do the collisions vary by time of day or road conditions or other factors that are in that data set. Okay, so you have a lot of variables in your data set, but we're just going to focus on a subset of them because a lot of them are kind of redundant or non-informative, actually. So by the end of the workshop, you will be creating this version of the data, which is essentially using ggmap to give you the Google map here of the same stretch, so M14 up through 23. Each black dot here is one of those separate collisions, like those red markers that we got from the previous map. And what we're plotting is over the course of a day, so on average, how many collisions are happening at 8 o'clock, 9 o'clock, 10 o'clock. So it's just cycling through to show you, the bursts of times when it's really bad on average, okay? So, inspiration for the rest of the workshop. How do we do this? Okay, so these are just some of the variables that I pulled out that you might be interested in from this collision data set. I mentioned things like time of day, day of the week, month of the year. They also code the road conditions, whether it's icy, wet, dry, lighting conditions, dark or light, what kind of crash it was. So, was it a fatal injury, just an injury, no injury? How many vehicles were involved? Was it a hit and run? Was a bus or a truck involved? Was the driver young or old? So they have their own criteria for that. But basically, I think old drivers are 65 and up or something like that. And also the general weather conditions. So again, you can look at any variable you're interested in, but I think these are probably the most interesting or informative to start with. Okay, so first we're going to look at some visualizations with this data set in a data exploration kind of mode. So the goal here is to efficiently and quickly switch between different formats of visualization, so bar charts versus scatter plots versus a map of the coordinates, and also plotting different types of variables like the ones we just went over in the previous slide. So ggplot2 is very nice for this goal because once you have your template or formula for how to create your base map or base plot, you can just very easily substitute different variables, different features, and very quickly kind of iterate through lots of different data visualizations. Okay? So for example, we might want to see just generally what is the overall distribution of the data. And you guys already had a sense of that from my example where I'm showing you over the course of a day, how things vary over time. It's a very dense data set, right? So there's like big clusters of collisions, like right on those on-ramps where the merge is really bad. So things like that. We also want to see, are there outliers or anomalies? For instance, maybe there are certain months of the year where collisions are much more frequent in this stretch, and you can kind of generate hypotheses about what those months might be. And we can also try to figure out which combinations of specific variables are the most informative. So, understanding things like time of day, road conditions, is there an interaction between those things, right? Okay. So let's get into ggplot2. So ggplot2 is based on what's referred to as a grammar of graphics, which is essentially just a template. And the template has several layers. You just add different layers to your plot, and I'll go over what some of those layers are. So essentially, you start with a ggplot command where you give the argument here your data, so data equals a crash in this case. And this command basically tells R to plot. So it's saying plot the data. Okay? But then we have to make some decisions. What are we plotting, right? So the next layer here is the template is a geom. It's referred to as for short as a geom. And this is essentially, what kind of data point are you plotting? Is it a bar chart? Is it a scatter plot with dots? Is it a histogram? And there are several different types of shapes of data points that you can use. So I'm going to show you a cheat sheet at the end that gives you all the options, but there's several. So you make a decision about the format of the data point. And then within that, you pass it an argument called mapping, where you're telling ggplot first, what are your x and y variables? So what are you going to be looking at in your plot? And that is also controlled in this AES section. AES is short for aesthetics. And aesthetics is kind of a broad term, but it generally refers to all of the visual properties of your plot. So not only, you know, what variables map onto the x and y, but things like, is there another variable that should vary by color or shape? Or you can control the transparency of your dots if you have a really dense data set. You can control the size of your dots. There's all kinds of features that you can play around with. And again, this is nice because you have this template, you can very easily just switch out different parameters very quickly to see what looks best or what's most informative to you. So let's start with our first plot. Oh yeah.
For those of us that are used to ggplot, those dinosaurs of us that are still doing ggplot, can you maybe just tell us what improves between ggplot and ggplot2, if you know anything?
I don't. I never used ggplot. Sorry. Does anyone else use has experience with old ggplot that knows differences? Do you want to say what are differences, or?
I don't have any specific example, but yeah.
Okay. So hopefully, mostly conceptually, it's similar. I would guess that there's maybe like new layers or kind of more advanced features. But yeah, I'm guessing the template part is similar. Okay, so we're going to start by making our first data visualization in ggplot2, and we're just going to make a simple bar chart. And in this case, we're going to start with that command ggplot, and in this case, AACrash is the name of your data set. So if you called it something else, use that name. But this is the data that's been imported already, so it knows what AACrash is. So you'll type that, and then plus is every time you add a layer. So every time you add data points or you want to change the axis scales or add titles, you're going to have a plus to add each layer. So the next layer for us is our geom. So because we're doing a bar chart, we're going to use this function, which is geom_bar. Okay. So geom bar takes specific mappings. In this case, we're just interested in the one variable of crash month. Okay. So if you look in your data set, if you go back to R and you look at the variable crash month, you'll see it's actually, if you're using the Excel version of the file, this symbol is a backtick. It's not an apostrophe. So make sure you know, if you do copy it from the slide, if you have the slide, it should be okay. But if you're just typing it, you know, from home or just looking at it, just make sure you use the backtick symbol, which is under the tilde key on your keyboard. Okay. So that is used because our variable in this case has a space in between the words crash and month. Most of the variables in this data set have spaces in them. So you just have to kind of group that variable name in backticks. If it's an Excel sheet, if you are using a CSV format, instead of backticks, you're just going to use a dot between the separated words, okay, to call the variable. So what this is going to do essentially is it's going to plot crash month on the x-axis, and ggplot2 defaults to plotting just a total count of how many crashes happen in each month. One thing you might notice is these months are not ordered chronologically. They're ordered alphabetically. So one bummer about ggplot2 is it defaults to, if the variable is a string or character, it's going to automatically order things alphabetically. And if it's a number, ordinal category, it's going to order it by number. So we can fix that. So how we're going to fix that to make it chronological is we're going to basically transform our variable crash month. The way to do this, if you don't have something related to time or dates, and you want to reorder your levels of your factor in a specific way, you have to type out all of the different levels in the order that you want. Luckily for us, there's a shortcut because we're reordering a date variable. The shortcut is just to type month name instead of listing out all the different variables. But I did want to show you this is a tool that you can use for other categories that may not have a shortcut if you want to reorder them in this way. So essentially what we're doing is we're calling the data set first, crash. The $ is a way to call a specific variable within your data set. So we only want to transform crash month in this case, so we're just going to type crash month after that $symbol, again in the backticks if you're working with the Excel version. You're going to type an arrow here, so left arrow dash, that's going to save this in the new variable. So we're basically creating a new variable with a new format and reordering the levels. Then you're going to type factor, so we're changing this now to a factor with different levels. We're saving it in the same variable, so just using the same format as before. Now we call this function levels equals C parenthesis, and then, like I said, the shortcut is just to say month.name, and that will automatically reorder them in chronological order. Okay? So once you've done that, you can replot your ggplot. So using the same exact formula as before. If you're not aware, there's a shortcut in R Studio where if you click the up button, it'll go to the recent commands that you did. So if you kind of press the up button until you get to this line of code, that's an easy way to replot if you don't want to type it out again. Okay. So, so you should have that stored, so you can scroll up to where your previous one is. And here we're not changing anything, right? So we've already just reformatted crash month to be in order. So you're using the exact same formula as before. Okay. And now hopefully your plot looks like this, where the months are chronologically ordered on the x-axis. Anybody not get that? Everyone good? Okay. What are some things you guys notice about this data set, just looking at crashes by month?
Bitter months.
Yeah? So February, one of the worst months, right? Also kind of a spike in the fall, right? When students are coming back and people moving in, maybe they're not used to that stretch of highway, and yeah, we've got some spikes basically. Winter and fall seem to be the worst, right? And that makes sense. Okay. All right. We're going to do another bar chart, but this time we're going to look at a different variable. So this time we're going to look at time of day. So you should have a variable called time of day in your AA crash data set. And you're basically going to use the same formula. We're just going to substitute the variable x equals time of day instead of x equals crash month. So again, this should be easy for you to do. You just scroll up to the previous formula here that you use and just type in time of day instead of crash month. And if you do that, you might get something like this, which looks a little funky again on the x-axis, right? So I should tell you, I downloaded the data set in its pure form except for time of day. I did go in and change the time of day variable from the original website because the time of day variable is coded as a string, as an interval between like 1 to 2, 2 to 3, 3 to 4. And that's a very difficult format to work with when you're working with time. You actually really want time to be either in a format that, there's a format that's basically based on time zone information or some kind of numerical format. So there are various ways to convert the time format, but I essentially went in there and did that for you. So your time format should be in that time zone format, okay? So the problem though with that is, you know, it's not really informative, right? So we're getting 0, 6, 12, 18, but it's got these dates in it, and we want to fix it, right? We want it to look something more like hours, minutes, seconds, okay? So let's go ahead and transform the time variable. So basically what we're going to do is change the format from class POSIX CT, which is time zone format, to a character with hour, minute, second information. And to do that, you're just going to type, in this case, the data set, a crash, $, we're calling that variable time of day, and then we're now storing that into a new format. So again, we're calling format. We're formatting that same variable, so the same words here. And now the format is in double quotes, %H, so that's creating the hour, colon, %M, that's creating the minutes, and then colon, %S, and then end quotes. So I only have hour information, but if you do this with an actual data set that has minutes and seconds information, it would include that. Was there a question? Sorry.
The date format is not function.
Which, the previous one you mean?
Yeah.
Collisions by time of day one. Ours has additional slots.
I get the same error.
That's not a function.
Oh, so you have outdated slides. Sorry, you guys have outdated slides if you're going from the one that was sent yesterday. So if you just follow this, if you follow this instead, it should work. Sorry, guys. I was playing around. So there's lots of different ways to get around this issue, and I was kind of playing around with different ways of doing it. So if you need to, you can re-import the data set and follow these slides instead. Okay. So should we go here? Is that okay? Yes.
So those tildes are the
backticks?
yes.
Yeah.
How do you get those without like copying and pasting from somewhere? Is that on your keyboard?
It's under the tilde key on the top left.
Thank you.
Yeah. Okay. So you should notice if you go to your R Studio, after running this code, you should see that the class has changed from POSIX-CT to character. Okay. Okay. So then if we replot this, so again, using the same code as before, we don't need to change our code here with ggplot because all we've done is transform the variable time of day to look somewhat more meaningful. And now you should get a plot that looks like this, where the x-axis now is ordered chronologically in a way that makes sense from 0 to 23. Okay. So what do you guys notice about this data set in terms of patterns?
Spikes are on the commute to the house.
Rush hour, right? Yeah, so starting as early as 6 a.m. to 9, 10 a.m. we've got a spike, and then again as early as 2 o'clock we've got kind of a spike again from 2 to 6, which corresponds to rush hour. Yeah.